Okay, so here we will be looking at the relationship between the linear expansivity and area expansivity using mathematical expressions. So how do we do that? Originally, we derive an expression for the final length of a wire during linear expansivity, and then we were made to understand that the final length of a rod or wire when it must have expanded is L2, which is equal to L1, then bracket 1 plus linear expansivity multiplied by the change in length. So at the same time, we were also made to understand that as the length of a plate is increasing, the area of the plate is going to be increasing, which means that the breadth of a plate, if in rectangular form, will equally be increasing by B2, which is equal to B1, in bracket 1 plus linear expansivity multiplied by the change in length. So what am I saying in essence? So I'm only trying to derive an expression that relates what? Area expansivity and linear expansivity. So, and we believe now that when a plate is heated, the length increases and the breadth increases. So originally from the mathematics, we already know that area is equal to length times breadth. Length times breadth. So, and this is the original area of this plate. So the area is A1, which is L1 multiplied by L2. Now, when the plate is now heated, so when it is heated, the area is going to increase to area 2. So let us say that the area 2 is now L2 multiplied by B2. So this is the area, the final area after expansion. Now we are saying that we are going to relate the linear expansivity with what? The area expansivity. So now let us define area expansivity. Area expansivity is the increase in area per unit area per degree rise in temperature. So how do we put that in mathematical form? So already we know that we represent what? Area expansivity with the Greek letter beta, okay, which is equal to area 2 minus what? Area 1 all over area 1 bracket theta 2 minus theta 1. So this is the mathematical statement of the area expansivity. So if we make A2 the subject, which is what we are looking for, then we'll now have that area 2 is equal to beta area 1 bracket theta 2 minus theta 1. So let us say that theta 2 minus theta 1 is equal to change in theta. Okay, so let's take this like this. So we now have that area 1, area 2 is equal to area 1 plus beta area 1, then change in theta. Okay, so factorizing, we have area 1 bracket 1 plus beta change in theta. Okay, but area, yeah, this is area 1. So this is going to be our first equation. Now let us now derive the expression now from the final length, so we can see the relationship between the final area from the definition of the area expansivity, and then that expression from the linear expansivity. So from the linear expansivity, we were made to understand that A2 is equal to L2 B2. Now A2 is going to be L2 is this. From the linear expansivity, we have L1 bracket 1 plus alpha change in theta, and then B2, which is this, will now be B1 bracket 1 plus alpha change in theta. Okay, so this is it. So we are going to expand. So expanding this, we have that area 2 is equal to L1 B1 bracket 1 times 1 is 1. 1 times alpha change in theta is alpha change in theta. Then alpha change in theta multiplied by 1 is alpha change in theta. Then alpha change in theta multiplied by the alpha change in theta is alpha squared change in theta squared. Okay. Okay, so that's it. So we continue from there. We now have that A2 is equal to L1 multiplied by L2. L1 multiplied by B1 is equal to A1. So we have A1 bracket 1 plus alpha change in theta plus alpha change in theta is 2 alpha change in theta, then plus alpha square change in theta square. Okay, so this is what we have. But since the linear expansivity is very small, so by the time we square the linear expansivity, we'll see that the value is now tending to 0. So it's so much insignificant that it won't impact in any of these equations. So, and that is why we are going to remove this expression. So, and then we have A2 is equal to A1 bracket 1 plus 2 alpha change in theta. So since this is insignificant, so now looking at this equation, so this is our equation 1. So let us try to compare the two equations. So we can see if we bring the equation 1 here, we are going to see that A2 is equal to A1 bracket 1 plus beta change in theta. So this is our equation 1. So when you compare these two equations, so you are going to match these terms, and then you see that A2 here, A1 is here, 1 is here, plus plus, and then I have 2 alpha here, and then I have beta here, and then change in theta. So we can see that the only difference here in the two equations is that beta is equal to 2 alpha, and that is the relationship between the linear expansivity and the area expansivity.